which numbers would you plug in to want to get a higher Cronbach alpha so that this gets closer to 1? Let's just think about it for a second. First of all, what would happen if you increase the number of items? Do you think that would make a difference? K is the number of items. If I ask 20 questions, how would that change that number in the formula versus asking only 4?
We'll lower it.
Okay, we have one person voting for lowering it, so you're multiplying it by 4 divided by 3 versus 20 divided by 19. What's it? If you're multiplying it, it's going to magnify, right? So what's the bigger number, 4 divided by 3 or 20 divided by 19? 20 divided by 19, so it actually makes it bigger. So if you want the Cronbach alpha actually gets bigger, because remember this is separated off. It's multiplication with parentheses, PEMDAS. This is separated out. So if you want to artificially inflate your alpha to cheat your scale, make it a 34-item scale. Every additional question you ask, even though your participant will hate you, is in the favor of adding to your Cronbach alpha. So how else do we get this to be a higher alpha? Well, this is what happens when it's 1 minus. So we want this number to be smaller, right? Because that number represents what you're subtracting out of 1. So if you want to make that number bigger, you want to subtract less from 1, right? So how do we make this smaller? How do we make this a smaller number? Well, which is going to need to be the biggest, the numerator or the denominator? The denominator. The denominator, yes, the bigger that denominator goes, the smaller that's going to become. So if you have, and what's that denominator? What is it? What is it? This. Someone just read it aloud. The variance associated with the observed total scores. That's where, remember we had to sum, because I was an idiot, I did an average at first. There you are.
So what if there are 4 questions but there is a lot of variance and 20 questions with very little variance?
Well, then you have, if it's very little variance, you get a really nice Cronbach alpha. With 20 questions with very little variance, your Cronbach alpha is great, because there's so much agreement, everyone's in a big party. But let's say you have one of those 20 questions, though, is a huge amount of variance. One of those 20 questions is like a variance of 100, where all of the rest of them have a variance of 10. Then what might happen? What's going to get bigger then? The numerator, right? The top number. And that means that this is going to become bigger, and it's still going to hurt you. So 20 bullshit questions, where some of them don't measure what they're intended to measure, where you have some of them have a variance of 100, and the other ones have a variance of 50, and it's all going to add to that numerator if they're poorly designed. It's going to add to that numerator. It's going to make that number bigger, and it's going to shrink your alpha. So you can, yes, you can inflate your survey by asking more questions, but you need to make sure they indeed are measuring the same idea, at least how they have similar variance. Otherwise, that numerator is just going to grow and grow and grow. So boring questions are good, but really crappy questions or just really different questions aren't going to help. So when you do this in statistical software, like SPSS, which is not available to you through GW, they will actually tell you how would the Cronbach alpha change if a certain question was dropped. So if the scale eliminated a certain question, would that improve the Cronbach alpha? Even though you do lose one question, so even though you take a hit on this side, you might gain because you cut off a question that has the variance of 100, while the rest of them have 20 or 10. So that will actually be reported to you in statistical software. But if you are ever, in your senior theses and your research lives, if you're ever asking about the same thing in multiple ways, if you can't tell them Cronbach alpha, you do not have evidence that all of your questions are being answered in the same way. And how many of you intuitively would have thought that respectful and civil reverse coding should, or let's just keep it simple, who would intuitively would think that a tweet that was rated as more rude would be seen as less respectful? Anybody would have that intuition? More rude, less respectful? Maybe. How about more rude, less civil? You'd expect some negative correlations here. In the actual data set, we only get a Cronbach alpha of 0.65, which is below most cutoff points. And that's because we only pay participants $2 to rate 3 tweets along various dimensions, and some of them were just not doing very careful jobs, or maybe some of them were ambivalent. Some of them might have challenged our intuitions. So we need Cronbach's alpha because if we just assumed that respectful and civil should correlate negatively with insulting rude, if we just assumed that, we would have been wrong in this case until fancier math was done with something called the multi-level structural equation model. So the point is, you don't assume you've got your Cronbach's alpha, and I have to beat that into the heads of so many seniors doing their theses. Like, if you're going to ask multiple questions and you want to treat them this way, we're going to need you to do your Cronbach's alpha. Because it's not intuitive. You're just like, of course these correlate the way I expect them to. You don't know your data. You don't know it until you get a number on it. Okay, so hopefully that helps you to understand why I had to go through this process. And understanding, you can think of scenarios and you can try things out and you can try to really understand what's causing problems here. And by the way, now that you know how to calculate the variance per question, as well as the total variance, if you notice that one question has a huge amount more variance, you're like, let me take a look at this freaking question before you even get to calculating Cronbach's alpha, because it's highlighted it for you as something that's a little different from the rest. So you have the tools to play detective, survey detective, and figure out, at least by the numbers, what questions are really similar, what questions are really different, and what questions are similar. You can at least play survey detective now, which is a good thing. So you do all of that,